Okay, so let's look at four problems here. So problem one says, what are the values of A and B? So if we take a look at this picture, A is an arc measure and B is an inscribed angle measure. All right, so let's look at A first. So A is this arc right here in blue, okay, from P to T. Now, if I trace it back to an angle, because this is an intercepted arc, trace back here, trace back here, notice the angle is 60 degrees. So the inscribed angle is equal to half the arc. So the measure of angle Q, I guess I should call it PQT, sorry, is going to be half the measure of its intercepted arc, which is arc PT. So 60 is going to be half of A. Well, remember, if you're looking for the arc, you can also write this equation as the measure of arc PT is equal to 2 times the measure of its inscribed angle, PQT. So A is equal to 2 times 60. And that means A is just 120 degrees. So again, remember, if you're looking for the arc, you double the angle. Okay, and now let's erase that, the beauty of an eraser. And again, if I were you, I'd make sure I write this, draw this picture somewhere. I'll change the red. So now let's look for the measure of angle B. So angle B is this inscribed angle. The arc that it intercepts is PTS. It is still a minor arc, so we could just call it PS. So the measure of angle PRS is equal to 1/2 the measure of arc PS. Well, PS involves A and 30. We just found A to be 120, so we're going to use arc addition to add 120 and 30 to get 150. So our angle B is going to be a half of 150, and half of 150 is 75 degrees. There we go. Okay, so again, if I'm looking for an arc, double the inscribed angle. If I'm looking for an angle, take half the intercepted arc. All right, next problem. Okay, so now we're looking for a couple of numbered angles. So we're looking for the measure of angle 1 and the measure of angle 2. Well, here's the measure of angle 1. It's an inscribed angle. It's going to be equal to half of its arc. Well, that's a bummer because we don't know that arc measure either. So how are we going to find this angle? Well, look here. This segment right here, I'll color it in red. This is a diameter. In your problems, it's very important to identify diameters because you then create 180-degree arcs because you create semicircles. So this arc here is a total of 180. Well, if this part is 70, we can use a form of arc addition and subtract 70 from 180. And you take 180 minus 70, you get 110. And now we have the intercepted arc for angle 1. Angle 1's intercepted arc is 110. So the measure of angle 1 is going to be a half of 110. That means the measure of angle 1 is 55 degrees. Okay. And then I'll go ahead and erase this. And now we're looking for the measure of angle 2. So if I trace the measure of angle 2, I'll use purple. So here's angle 2. So again, goes to this arc. Oh man, I don't know what this arc measure is. Oh, well, let's just use 70. Oh no, this right here is not a diameter this time. So we can't just take 180 minus 70 again. It's not going to work, not a diameter. But wait, they give you this 38. Why do they give you this 38? Well, if we trace the angle 38, it intercepts the exact same arc that angle 2 does. That means that this angle, 38 degrees, and angle 2 are congruent. So the measure of angle 2 is just also 38 degrees. Again, we could also double 38 to get 76. This arc is 76 degrees. So then take half of it to get the measure of angle 2. Half of 36 is 38 degrees. So you can use the corollary that says inscribed angles that intercept the same arc are congruent, or you could double the angle to get the arc and then take half the arc to get the angle. Whatever you want to do. Okay. Next one. All right, so now we have 4 angle measures. We got to find all 4. Let me just scroll down so we can see. So if I'm looking at this picture, the first angle I'm going to find, well, I have a diameter. Let's identify that. So this is a diameter. Creates 2 semicircles. So if that's a diameter, that means this is a semicircle and that's a semicircle. So if you look at this top, let me erase the bottom one. If we just use this top semicircle, the angle that intercepts that arc, or the inscribed angle that this arc is the intercepted arc, is angle 3. Well, we have a corollary that says that the angle that intercepts the semicircle is a right angle. Angle 3 is going to be 90 degrees. I think we can do the same thing with angle 1. If I trace angle 1 in red, it opens up to this bottom semicircle. So angle 1 is also going to be 90 degrees. This also verifies the idea that in inscribed quadrilaterals, opposite angles are supplementary. Angle 1 and angle 3 are opposite angles. They should add to 180, and they do. 90 and 90. Just how to be the same. Okay, and now what about angle 2 and angle 4? Well, angle 4, if you trace it, opens up to this arc here, right? Angle 4 is an inscribed angle. And we know the 2 parts of this arc that make up this full arc's measure, 60 and 80. If we add those, we get 140. So that means that the measure of angle 4 is going to be half of its arc, half of 140. And half of 140 is 70. So the measure angle 4 is going to be 70. And then angle 2 is an opposite angle to angle 4 in this inscribed quadrilateral. To find the measure of angle 2, we're going to take 180 minus the measure of angle 4 because they are supplementary. Opposite angles of a quadrilateral inscribed in the circle are supplementary. So that means angle 2 is 180 minus 70. Angle 2 is 110 degrees. There we go. So that's that last corollary involving an inscribed quadrilateral. All right, last but not least here. So now we have that picture of that tangent. So in this problem, it says SR, line SR is a tangent to the circle at Q. If the measure of arc PMQ, so PMQ, if that arc is 212, what are the values, of A and B? Well, A is this angle formed by, I'll do it in red, A is this angle formed by PQ, this chord, and QS, that part of the tangent. So A is just like an inscribed angle, will be half of its arc. So A is going to be half of 212. Half of 212 is 106 degrees. And then to find B, B is an arc in the circle. And in these problems, the circle, which equals 360, is only broken into 2 arcs, the 212 and B. So together they must add up to 360. So to find B, takes 360 and subtract 212. 360 minus 212 is 148. B is 148 degrees. Now, just to check yourself, if B, and I'll do it here in green, if B is 148, then what is the angle measure here? Well, it's going to be half of 148, which is 74 degrees. And now A and this angle form this tangent line. They're a linear pair. They should be supplementary. So let's look. 74 in angle A. 74 plus 106 is 180. So that's a quick, easy way to check to make sure that you are right. The two arcs should add up to 360, and those two angles should add up to 180. All right, very good. So hopefully you have a firm grasp on inscribed angles and do well on this assignment, which again, I think the state test really enjoys. All right, thanks for watching.